Hello everyone, myself Dr. Hemukumar. In this session, I will be discussing about mathematical library functions used in C++. Introduction to mathematical library functions. Definition. Math library function provide a range of mathematical operations that can be used in C++ program. Purpose is simplify the complex calculation, ensuring accuracy and enhance code efficiency by leveraging standard mathematical functions, including the mathematical library. So we need header files to use the mathematical library function in the include. So it is hash include cmath.h is used to include the math library. C++ mathematical functions. C++ begin a superset of C supports a large number of useful mathematical functions. Those functions are available in standard C++ to support the various mathematical calculations. Instead of focusing on implementation, those functions can be directly used to simplify the code and program. In order to use those functions, you need to include header files math.h or cmath.h. Mathematical library functions in C++. C++ provide a large set of mathematical functions which are stated below. Function description. Double sign of double. The sign this function takes angle in radians as an argument and returns its sign value that could be verified using sine curve. Double square root of double. This function uh, takes a number as an argument and return its square root value. The number cannot be negative values. Int abs of int. This function takes an integer number as an argument and return its absolute value. It means the output will always be positive regardless of the sign of the input. Double POW, that is power, open bracket double comma double. This function takes one argument as a base and another as an exponential. Double HYPOT, open bracket double comma double. This function requires two sides of the right angular triangle to give output as its hypotenuse. So this gives a hypotenuse in a triangle angle. Double floor of double. This function returns integer value lesser or equal to arguments passed in the function. Double seal of double. This function returns the smallest integer as double not less than the argumented provided. Double log of double. This function takes a number and returns the natural log of that number. Double exp, that is exponential of double. This function returns the value of e is equal to 2.718 rises to the giving number. Example of C++ mathematical functions. The common mathematical function overviews are like this. Base operations, basic operations, that is ABS, SQRT, POW, CEIL seal, floor, FMOD are the basic operations. Trigonometric functions are like that: sine, cos, tan, a sin, a cos, a tan, like that. Exponential and logarithmic functions are like that: exp, log, log base 10 and power are the exponential. Miscellaneous functions are like that: round, hypo, hypoto, in, is nan, is infinity, etc. are the functions used in the miscellaneous. Common mathematical function used in C++ programs. ABS returns the absolute value of an integer. For example, we write like this: int abs open bracket int n, means the parameter is passed in and it returns the integer value. FABS returns the absolute value of a floating point number. So example, the declaration is like this: double FABS open bracket double x. Double is a data type, x is a variable which holds the double data type and returns the double value. POW, that is power, compute the power of a number. Double power open bracket double base, comma double exponential. Base and exponent are the two variables which I need to pass in a power function, and it returns the double value. SQRT, compute the square root of a number. Uh, the way we write like this: double SQRT open bracket double x. X is a variable of a double and returns the double value. Ceil returns the smallest integer greater than or equal to the input. Double ceil open bracket double of x. Floor return the largest integer less than or equal to input. Double floor double of x. Round the input to the nearest integer. Double round open bracket double comma double of x. Sine, cos, tan are the trigonometric function used to write like this: double sine of double angle, double cos open bracket double angle, so double tan of double angle. So this angle is the variable which is a double type. Practical applications of mathematical functions. Engineering. In engineering, calculation involves force, momentum, and other engineering matrices. In the graphics, rendering the transformation and shading calculations. In data analysis, statistical and data fitting operations. These are some example where the mathematical functions are used. Here is a C++ program to illustrate some of the above mentioned functions. Carefully observe the slides because you will be learning how the functions, mathematical functions are used to get an output. First, you have to write the hash include iostream.h, hash include cmat.h. Using namespace std int main open bracket double x equal to 2.3. X is a variable we are given the value of 2.3. So see out the sine value of x equal to 2.3. You can write like this: sine of x underline, then again cos of x, then tan of x. You can write double y is equal to 0.25, the variable you have declared. So you can see out square root value of the y equal to 0.25, square root of y, you can get the output. Again we can check it as absolute value. We will declare that int z equal to -10. See out absolute value of z equal to -10. So abs of z, again the power value of x and y, you can write like this: power of x comma y, you will get 2.3 into the power of 0.25, it will compute. And x equal to 3 and y equal to 4, two variable values we have taken to compute. Hypotential having other two sides as x equal to 3 and y equal to 4, you can use like this: hypot of open bracket x comma y, you can get the hypotensor. See out floor value, you can compute for the 4.56, the floor of x. So x equal to -4.57, absolute value of -4.57, you can use FABS of x, you will get the absolute value. So x equal to 1, the arc cosine value of x, you can compute a cos of x. Again you can use a sin of x and a tan of x. Y is equal to 12.3, you have given any number you can give. For example, we have given only these numbers. You have to write like this how the code is used. See out ceiling value of is y equal to 12.3. So ceil of y, it will be sealed. X equal to 57.3 in radians, you will give. The hyperbolic cosine can be computed using cos h of x and tan h of x, so you can compute. And y is equal to 100, we are given natural base of e, you can compute like this: uh, log of y, it will give the natural base with e, return 0, end of the main function. This is how some demos we have demonstrated how the mathematical functions are used to compute, and you just check this program how the output will be outputted, and what will be the output will comes in the we will be explaining how the results will be displayed. In the above shown program, we are giving that output, how the output uh, will be extracted. So you can just check the program by coding yourself also, and you compare this whether the output will coming like this or not. So output for the first, we have computed sine value of x equal to 2.3. The output will be 0.745705, and cos value of x equal to 2.3 is equal to minus 0.666276. Again, tangent value of x equal to 2.3, it gives minus 1.11921. Square root value of the y equal to 0.25 is equal to output will be 0.5. Absolute value for the z equal to minus 10, output will be 10. The power value of x to the power of y is equal to 2.3 cap 0.25. We have given input. It gives the output as 1.23149. Hypertensor having other two sides as x equal to 3 and y equal to 4, it comes 5. Floor value of the x equal to 4.56, it gives the 4. Absolute value of the x is equal to minus 4.57, it gives the 4.57. Arc cosine value of the x 1, x equal to 1, it gives the 0. Arc sine value of the x equal to 1, it gives the 1.5708. Arc tangent value of the x gives the 1, for x 1, it gives the 0.785398 value. Ceiling value of the 12.3, it gives the 13. Hyperbolic cosine of x is equal to 57.3, that is 3.83746 plus 24, it gives. Hyperbolic tangent of x equal to 57.3, for 57.3 it gives 1. Log value of the y 100 is 4.60517, it will gives. Like this you can compare the program output, how the program will be outputted using the mathematical functions. Thank you.